Okay, so typical examples of EMC problems. So one I've already shown. So are you aware of other EMC problems now because you know what EMC means that you have experienced during your daily life? So very often you hear your smartphone in the loudspeakers of your stereo just before you receive an SMS or before the phone rings. What's here the problem? It's also an electromagnetic interference problem because the base station is communicating with your smartphone, so it sends some data. At which frequency is the smartphone communicating with the base station? 800 megahertz, 1.8 gigahertz. Can you hear this? Usually not. What frequencies can you hear? Or which frequency ranges can you hear? So basically,
2 to 2 kHz, up to 20 to 20,000 hertz, right?
So depends on your age. So young people can hear up to maybe 20 kilohertz. When I was younger, I was going also to a discotheque, so maybe my hearing aid is not that good anymore. But the older the people get, usually the lower gets the frequency range, so usually in the 10, 15 kilohertz range, also up to 10, 15 kilohertz. So why can you hear then the smartphone communicating with the base station if the communication is at 1.8 gigahertz or 1.9 gigahertz? Because you cannot hear the 1.8 gigahertz. So why do you hear this quick, whatever it's called? Noise in the loudspeaker.
Yes, some interference is injected into the cable of the loudspeaker probably.
Yeah, it's mainly the interference from this high frequency carrier signal. Because you have to think also about wavelengths. So the wavelength of a 200 hertz signal, this is usually what you hear, that is pretty big, and it's much, much bigger than the cables on your stereo, because in stereo you have the main stereo thing, and then there's a cable to the loudspeaker. So usually this long cable, even if it's 2 meters long, is not a very good receiving antennas for noises of 200 hertz, because it doesn't match the wavelength. But it's a very good receiving antenna for high frequency signals. So 1.2 gigahertz has a wavelength of 60 centimeters roughly or something.
Roughly.
Yeah, so it comes in the dimension of the loudspeaker cable. So the loudspeaker cable can act as a receiving antenna, catches the radio frequencies or the high frequency noise. And usually this high frequency communication is a pulse communication. So there are pulse packages which are transmitted with whatever, 200 hertz or whatever. And then it's demodulated within the amplifier, for example, or within the nonlinear structures of your ESD protection structures of your ICs. So it's demodulated, and then you will finally end up with a noise signal of 200 hertz or whatever inside of your amplifier. And the amplifier usually can amplify 200 hertz pretty easy because it should amplify audio signals. And then the amplifier gives this 200 hertz or whatever it is, low frequency signal to the loudspeakers, and that's the noise that you hear. Also a typical EMC problem.